Let me begin with it again. So after you are done with the installation of the VMware, you would start it from the desktop. Then you would see the previous screen. Let me remove it again and add it again. So you would see this screen. You click on open a virtual machine. So virtual machine, the open lane that was shared with you, click here, and then you browse to the folder where you extracted the open lane files. And then you select this open lane Ubuntu .vmx file. You click and open here, and then you are able to set it up. So you should have at least 4 GB of memory so that the virtual machine runs smoothly. And then you simply press power on this virtual machine. So the virtual machine would now run. You could make it full screen by pressing Control, Alt, and Enter. So if you press Control, Alt, and Enter simultaneously, it would go into full screen mode so that you are able to see it better. Now it's logging into the or starting up the virtual machine. This is basically the complete Linux operating system in which the tools are already installed. So now it's running. So after it's done loading, you would see this screen in which you have a username. It's called Open Lane. You click on it, and then you have to enter the password. Password is in all lowercase, Ali, CUI, and then 2022. This is the password. You enter it and then press enter. Ali CUI 2022. Then you would log in into the Linux operating system. And the desktop appears. Now it's good to create a folder in which all your design files would reside. So I would, on the desktop, I would create a new folder called workshop. Create. And then I go inside it. And then this folder is initially empty. So I create 2 more directories here, 2 more folders. One is called schematic. And the other one is called layout. So we would do the complete flow schematic as well as layout. So we need to have 2 different directories, one for each type of file. So layout would be done inside the layout directory and schematic would be designed inside the schematic directory. Now, you go inside the schematic directory because in the beginning we start off with the schematic design. So I go inside schematic and I create a another folder called simulation. It is required, it's not necessary, but it's required for easy setup of the tools. So you create it. Now we have to copy certain files into these folders. So first of all, inside the schematic folder, not in the simulation, in the schematic folder, we need to copy a file which connects the schematic capture software with the Sky 130 process, where the models are there. So I would go to the main directory and how do I go? Oh, so I probably click on other locations. So I went onto other locations and then computer. Inside the computer, you would have this is the system. These are the system files. You normally don't tamper with them. You don't delete anything from there because if you do so, the software would not work. So we go into user first. We went on to other locations, then computer, and then go into user, then local, then share, user local share. The path is already on top you could see it, user local share, and then PDK. PDK, all the technology files are residing. You see some files here, folders here. Then you go into Sky130A, the user local share PTK Sky130A, then libs.tech. And then you see xschem is the schematic capture tool. So the files related to xschem are inside here. Those related to the simulation software ngSpice are here. So in the schematic folder, we should copy some file from this one. So we go inside xschem now. So if I expand it here, so you see we are user local share PTK Sky130A libs.tech and xschem. So from here, I copy a file called xschem.rc. So I copy it and paste it inside the uh, simulation, the schematic folder inside here. So I paste it and then I go back. So what did I do? I copied the file xschem.rc from inside the xschem folder in the PDK. And then next I would go back here and I go one step up again. So from libs.tech, I go inside now ngSpice and I copy this file sp init. I copy this file and I paste it inside the simulation folder and I rename it sp init file. I rename it to dot spice init. What do I copy the file and I rename it to dot spice init and I rename it and that's it. I go back to now schematic folder again. So what I've done is I have copied two files. One is the xschem.rc, which is required for the schematic capture tool to link to the Sky130 process. And the other one is inside simulation folder. That is for the ngSpice. So right now I'm inside the schematic folder. I can invoke the command to run the terminal. What I would do is I would right click here and open in terminal. If I do so, it brings up a terminal with the directory which I'm working in. So desktop, workshop, schematic. I hope everybody has followed until this point. Dot spice init. So question is, what is the name of the file that I rename it to? Dot spice init. Dot spice init. You have to copy it. If you cut it, then it would cause problems. So so now everybody is fine until this point. So here we now invoke the command for running the schematic capture tool, which is xschem. So I simply type xschem. If I do so, it brings up the window for xschem. So if you run the xschem command, xschem, xschem. So I could bring it here. So this is the command that we have run, xschem. Might find some errors, but they are not important. ठीक है, if you have any issue you could ask. कहाँ पे आपको मसला आ रहा है? So हमने क्या किया है, पहले तो हमने एक अपना अलग फोल्डर क्रिएट किया जिसके अंदर हमने लेआउट और स्कीमेटिक बनाए। अब हम स्कीमेटिक के अंदर आए, वी क्रिएटेड वन मोर फोल्डर कॉल्ड सिमुलेशन। अब हमने दो फाइल्स कॉपी करनी है, एक फाइल जो कि xschem को बताएगी कि स्काई 130 की जो फाइल्स हैं वो कहाँ पे हैं, उसके जो पास है या वेरिएबल्स की डिक्लेरेशन है। सो फॉर दैट वी कॉपीड फाइल कॉल्ड, मैं बताता हूँ, सो वी कॉपीड इट फ्रॉम user local share ptk sky 130a libs.tech ng spice. First we copied from xschem, so it's from sky 130a libs.tech xschem. We copied xschem rc file and we pasted it as it is in the schematic folder. Number one. Number two, from the libs.tech folder, we went inside the ng spice folder and we copied spinit file, but we don't copy it as it is, we rename it. So we copy it and we go into the simulation folder, we paste it inside here, and then we rename it to dot spice in it. Dot spice in it. This would make us ready to start making the schematic and proceeding with the process. The next step was to go back to the schematic folder, right click and open terminal. So where you would invoke or run the command xschem, this xschem rc file should be there, right? If it's not there, it would not be able to link. So therefore we run it from this folder. So you see that when I run it, I am already inside this folder. Desktop, workshop, schematic. So to know whether my copy directory, when you run the xschem command, you would see this page. If it's not copied there, it would create an empty schematic. So to be sure if it's correct, then you could press F to do it full screen or display the full contents of the file. So now what we'll do is schematic no schematic or schematic in the simulation. हारिस आपने कर लिया? आपका हो गया सबका? So you are seeing this page now. We could now this has standard cells and some scripts to test if your PDK is successfully connected. Instead, create our own schematic and then run it and see if it's working. So So now let's create a schematic of our own. What we'll do is we'll create an inverter and create it as a cell so that we could use it somewhere else as well. So, and then we would create a bigger schematic in which we invoke the inverter and try to simulate its DC characteristics as well as transient behavior. So I go to File and New Schematic. Now, before you could run it, you go to first of all options and see whether Spice netlist is selected on the bottom. So since we are doing a schematic design, so the simulation would be done on a Spice netlist. You could also use Verilog and VSDL netlists here, but they are generally done using the other automated synthesis flow. So here, this should be selected. Number two, you go to simulation and configure simulators and tools. And here, the first option ngSpice should be terminal -E. It is already by default selected. And number two is uh, okay. Hang हो गया. I have to restart the machine because it's stuck.
terminal log per execute.
Hang हो गया बिल्कुल. Let me pause it and okay. मेरा errors क्यों आ रहे हैं? I think I need to shut down. Restart. Maybe we need more memory. Maybe increase memory. So the second thing that you need to check is the viewer. So viewer should be ngSpice viewer. It could be external viewers too, but we will use the default internal viewer of the ngSpice. That's it. If it's already like this, you don't need to do anything. Just close it. Then you save the schematic. So since I'm trying to make an inverter, so I would have a meaningful name for it. So I would to file. File, save as, and you see here, you should save it in the working directory. So it's desktop, workshop, schematic, and here you give the name. So I call it my inverter, my INV, and then I press OK.
Just to so we have to make sure that the simulation is in spice simulation. And so it's a spice necklace. And then do we have to do anything with the view as well? Fine.
So one is under the options, it is by default Spice netlist, but we have to confirm that Spice netlist. Number two is the go under the simulation and configure simulators and tools.
Save it by
Inside that, the ngSpice option should be terminal -e. The other one is also ngSpice, but that's a batch command that is run from the terminal.
Sure.
So second thing is the viewer. So that viewer should be terminal ngSpice viewer. That should be selected. Okay, now we have to um, save it first with a meaningful name. Now we import the
we save it in the workshop folder.
workshop schematic. And inside schematic, you have a simulation folder where you have a spice init file. Now, to bring up a library, we press Shift I. If you press Shift I, you would get this. To get a symbol, you could directly get it from the menu as well. So you click on symbol. Tools. So you press insert symbol. It will bring up this. So on the left, you see three different directories or paths. One is the generic xschem library. One is the current working directory that you are working in. And next one is the PDK folder, user local share PDK Sky130A. So you click on this guy on the bottom from the PDK, and then you go into Sky 130 FTPR. So this is the one of the definitions. So once we click in here, you get all the devices. What we did is that when on the left side, we chose the bottommost, the user local share PDK folder, and then we went inside Sky 130 underscore FT underscore PR. And here I bring up the N MOSFET. So I take NFET underscore 01V8. So it's a 1.8 volt standard MOSFET. There are other types too, low threshold voltage as well, but we would use this basic device. I press OK. And to zoom, I press Control Z to zoom out and Shift Z to zoom in. If I press Shift Z, it would zoom in to make it, or I could directly press F to make it big. So if I want to zoom out, I would press Control Z to zoom out. So this is the first device that we need. So once we are done with this, so to make an inverter, we need a PMOS as well. So I press again Shift I, and I scroll down and I pick a similar device, PFET underscore 01V8. PFET 3 nahi. PFET 3 would, I think by default has source and drain connected. So we take the most generic device. It is this one. So PFET underscore 01V8. It will give you 4 terminals. And I place it right. You could see that there's a bubble at the input, which means it is inverting. So it will turn on for 0 and turn off for 1. So now we need to connect the various terminals together. So to connect, you use the wire command. So in the tools, it's insert wire is W. So I could directly press W. So wherever the cursor is, it would start drawing from that point. So I press W where I want to start. So I move the cursor to the drain. I press W and then I move the cursor, and where I want to end, I would left click. It is finished. Similarly, if I want to connect the gates, I move to the gate, press W, move, and click. It stops. Then I want to move down again, so I bring the cursor here, press W, move down to the point where I want to stop. And again, I left click, it stops. Then again, I want to start from here, W. This way you have connected the gates together and the drains together. If you want to move it, if you want to move something, you click on something, you select it, and then press M key. M to move, it would move it. If you want to undo, you press U for undo. If you want to copy, you could select something and press C. It would copy, create another instance of it. C for copy, M for move, U for undo. If you want to delete it, select and then press delete. So I make another connection here, W, like this. So I will take the input at the gates together, and I'll take the output at the drain. So therefore I bring out a wire. Then you need to connect the body terminal to the source. So I press W here, click here, W, and W. This way I have connected the body to the source of the PMOS. I again press W here and bring out another wire out. Similarly for the NMOS, I move the cursor here, W, click, W, click, W, click, W, click. So now all the terminals are connected the way we want. If you want to look at the properties of any element, be it a capacitor or a resistor or a MOSFET or any other device, you select the element using left click and then press Q. Edit properties toolbox comes out. So it's generic. So everything for anything, if you want to check the properties, you select the element and press Q. Q for query. Right? So here you see that of the MOSFET, which is 0.15. So Sky 130 process comes with a scaling factor of 1 micron. So 0.15 means 0.15 micron, which is 150 nanometer. Similarly, the width is 1, which is 1 micrometer. NF is the number of fingers. If you want to do a multi-finger design, like if you want to have one gate split, normally we won't do it here. It's not necessary. So the only two important numbers are the length of the MOSFET and the width. Now you see there are other parameters too here, other properties too. AD is the area of the drain. PD is the parameter of the drain. AS is the area of the source. PS is the parameter of the source. These parameters are required to compute the capacitances. As you see that there'll be a PN junction between the source and the drain region to the body regions. Therefore, the PN junction would have certain capacitance. And in the schematic tool would estimate the capacitances using these areas and parameters. It automatically does it. So now you also see in the second last line that it has a model name NFET_01V8. So this definition is inside the PDK folder in the user local share PDK. So we have to include a library that includes the definition. So we'll probably do it at a higher level of hierarchy, and because we are doing a hierarchical design and we design this inverter as a cell. So wherever we will use that cell, we will include the library file over there. So now what we do is this is the schematic and we want to create a symbol view for it. So symbol would be again a graphical thing inside which the circuit resides. So therefore we as an interface, we give the ports here. So if you want to apply ports, it is important the numbering as well. So if you have different numbering here and different numbering for the symbol, it would make errors. So therefore, you should be aware that the order in which you number. So generally what I would do is the port number 1 would be the input port. Port number 2 would be the output port. Port number 3 would be the positive supply and port number 4 would be the negative supply. So therefore, if you want to make a port, you go again to Shift I. So we are already in the PDK. So the port is a generic thing, which should not be in the PDK. So we have to go up, and then we go on into the xschem library, the local share xschem library. So this xschem library contains all the generic elements. Like if you want to add a voltage source or a port or maybe a current source or so. So we click here and then we go inside devices. So what we did is we chose the first library, which is the generic xschem library, and then we click on devices. Now you see again a bunch of elements. Here you see and a ground symbol, you see an inductor, you see current source and so on. So right now, since we want a port and first port, as I said, would be the input port. So I click the I pin symbol. I pin is for the input port. So I select this, press OK, and I connect it to the input side. Since this input terminal would be driven by something, so you have inserted an input port, then we need to have a name for it. So what we did is we again press Shift I, we went back to the up directory and then we selected the generic xschem library. We went into devices, we scroll down and chose I pin. I pin is for input pin. I placed it, and if I want to change the name, I would select it and press Q. Whenever you want to change the properties, you would select the item and then press Q. So in the label, you would type in. So again, maybe Spice would not be case sensitive, but when you would do the layout versus schematic, so the case of the name would be important. So if you make it a convention that you name all nodes uppercase or lowercase so that you don't get an error. So I would name it lowercase, but it's upon you if you want to select uppercase or lowercase. But be consistent. If you want to use uppercase everywhere, use uppercase. And if you want to use lowercase, let's use uppercase here. So we have now created an input port. This is the interface for this schematic. And you see as well that it is P1. So the port numbering is 1. So you have to be aware that the ordering of the ports should be consistent with the symbol. And next we want to add an output port. So I again press Shift I. And I
Search the components.
Anji?
Can you search the components?
I don't think so. You're not allowed, but I go to O pin. And I place it here. You see the direction too. I again press select it, press Q, and I call it out. OUT out. Then I need to add ports for the positive and negative supply. So I again press Shift I, and I should find a symbol called I open. I open. Just above I pin is I open. So to rotate, I press Alt key and R together, so I could rotate it. So you could, if you want to rotate another element, you would select it and then press Alt and R. So this is the IO pin for positive supply. I select it again, Q. I should save it as well. Yeah, we'll be It's good to save as you progress. Otherwise, I think for me, it's now stuck again. नहीं यार ये किसी और का इशू तो नहीं आ रहा है जो मेरा आना आ रहा So it's better that if you do some progress, Control S to save. Don't lose it. Yeah. So I maybe restart it. What we're doing is we are doing a hierarchical design. So this is meant to be a interface for the symbol. And if you want to simulate inverters, you would create a symbol first, instantiate that symbol in a bigger schematic, like the way you do it in, let's say, Verilog, you create a module and then create an instance. So that's what we're doing. Luckily for me, I have already done it, so I have a saved schematic. I'll simply copy it. Schematic and my input. So I send it to the desktop. I replace it. You see, I just want to cross check if the order is fine. Pin 1 is in. Pin 2 is out. Pin 3 is VP and pin 4 is VN. Now we would create a symbol for the schematic. So I go to File. Everybody is done till this point? So now we create a symbol for this. So I go to File and New Symbol. Now, the trick here is that you should name the symbol exactly the same as the schematic. So otherwise they would not connect. So I save it as. The only difference is that the extension would be SYM. The extension for the schematic is .sch and extension for the symbol would be .sym. So I name exactly my inverter .sim. So for you, if you have named it differently, you would name exactly the same. Now we have to create a graphical look for it. We would also create then pins to which the internal ports would be connected. So yes, save it as a symbol. Then to make maybe a finer looking graphic for the symbol, we have to reduce the snapping. So maybe if you press G, it will reduce the snapping grid. So make it 2.5 so that you could make a finer line. So if you want to make a line, you could again go to tools and insert line. It's L. So you could simply press L. It's the same as wire, but line is just a graphical thing. It's not a physical wire. So when you're drawing a circuit schematic, you would use W wire. If you were drawing a symbol, which is not meaningful in terms of the circuit, you would use L. So I press L and exactly the same. I start and end. So it's finished again. So again, I move the cursor here, L, and stop it here, and I press the L. So I make it look like an inverter. So next is to insert a circle at the output. I go to tools, insert circle. So for circle, you have to click 2 points, first point for the circle, second point for the circle, and then move to make a third point on the circle. So it makes a circle. So I may repeat it. So you press, go to tools, insert circle. So you first click here, then move to the second point, how wide you want the diameter of the circle like this, and then you move the cursor and you could make it bigger or smaller. So then I click again, it would stop so you have to click thrice, 3 times. 1 point, second point, and third point. Now I make another line. I press L like this. I press at the input And then for the positive and negative supplies, this is a physical symbol. So now to put the pins now, which would connect to the ports, get back to the snap at a higher level. So I press Shift G and get back to 10. इसको save भी कर लें, Control S. Now you need to bring in pins. So you go to again symbol and then place symbol pin, Alt P. And now the order of the pins should be consistent with the order of the ports that you have in the schematic. So I can simply press Alt P and it would. Generally, it's better to place the pins first and then, because I've increased the. ठीक है, it was better कि मैं 4 pins पहले put कर लेता और अभी थोड़ा ये गड़बड़ कर रहा है. हाँ. नहीं 2.5 पे फिर it would cause problems in the schematic. वहाँ पे generally बड़ी होती है. So I would. So it's better to start with the pins first. So you add 4 pins and then create the symbol around them. Alt P. Inside the tools, it's there. Tools, sorry, a symbol inside symbol. Place symbol pin. So I would simply copy it. Work. मैं इसको कॉपी कर लेता हूँ. For the pin, you would enter a name if I queue it. So it's the direction is in and name is. Order should be in, out, VP, VN.
So we're in the link. Did we start label? Labels. Oh, just the names. Yeah. Okay. Yeah. Name doesn't get it. Access.
Direction would be consistent with in, out, or in, out, depending on what the port is. जब आप ग्राफिक ड्रॉ करेंगे ना सिंबल की, यू शुड लोअर द ग्रेड, तो फिर आप फाइन उसको कर सकते हैं. इट डजंट मैटर, ये एक सिंपली एक विजुअल आपका है. इट डजंट मैटर कि वो कनेक्टेड अगर नहीं भी है, इट्स कनेक्टेड इंटरनली from the schematic capture tool. अगर ये VN की पेन इसको टच ना भी करे तो ये it's merely a line, right? It's just a graphical representation of what's inside. और जो connection is
The names have to be
exactly
yeah.
same name.
Case sensitive.
Yeah, case sensitive too. Maybe here it doesn't matter, लेकिन जब आप LVS करेंगे तो फिर वहां पे मसला बन जाएगा.
Sure. So I can see like you can see labels. I cannot see labels.
If you simply press outside and press Q, I think it shows here. So type is primitive. Could you tell me what's the type of your symbol?
I don't have any.
If you press outside, press Q. Yeah. If you have not named it, or name the schematic, name this, and then it will should automatically get it.
Yes. So what should be the direction? You know.
अगर save किया है, now उसका नाम इन्वर्ट डॉट SCH select here. Then click on the pen. Just it should be same name as the port name in the schematic.
The direction is what should be the direction?
इस सेम उसके साथ
We करेंगे it's already.
सेव करो. Sometimes it could happen कि आप गलती से 2 दफा कॉपी कर लें, तो उससे ऊपर नहीं जाते हैं, you are not able to see. तो be aware कि आप एक ही चीज पे डबल कॉपी कर लें. अब नहीं जाना, आप उसको नहीं है अब उसके and direction is प्लीज चेक के आपके पास जो ये पिन्स हैं, ठीक है वो देखते हैं सर. Q you press Q here,
Set by the. Just a little bit.
Getting again stuck. So name should be consistent with the first port of the schematic, which is in, and dir is the direction is in. Similarly, for the output pin, the name is out and direction is out. And for VP, VP should be name should be VP and direction should be in out.
That's right.
These display would normally bother you. Would not like them to be there. They can there's a way, I think you could display them.
The labels. Yeah, it's a thing, I mean, they're fine, but just because we didn't do anything, it just came.
I just copied it from yesterday's.
Okay.
I think it came by default. If you name them originally the beginning before making the symbol, if you name the schematic and then create the same symbol, I think it somehow links.
So, and yeah, maybe we could try it. So anyways, we have it without the labels now. It's fine.
I need to check. So, sir, could try can you please? So just press Q in the empty space. Then type is equal to sub circuit. And then format is equal to in the double quotes add name, add pen list, and add sim name. So it would add the 3
This is for the, this is for the, or
for the display for displaying. So whatever you write here would be displayed. So if you want to,
on the canvas, right?
yeah, exactly.
Tag,
The question is, if you want to display the pin names as well as the symbol name,
subcircuit.
so you would click outside here, press Q, and this text input dialog box comes up. You type this. So type is equal to sub-circuit, not primitive, sub-circuit. Then on the next line, you write format is equal to, in the double quotes, @name, and then @pin list, and then @sim name. Sim name is the symbol name, which is my inverter. Pin list is the all the pins that you have, and name is the instance name. For example, if you make an inverter 1, it will be maybe X1, X2, X3 in the bigger schematic. Sim name. If you want to display the name of the symbol that you're using, so it's my inverter, so it would as it is. Template is the names are named X1, X2, X3. That's it.
Yes, sir. जब हम copy करते हैं तो next पर two कर देते हैं फिर
जी,
copy
जी,
करते हैं.
exactly, exactly.
And what is the template in quotations? For the quote?
On
Template is equal to
the third, its name equals to X1.
X1.
It would then sequentially name the other instances X2, X3, and so on. So I think if you have already named the schematic and then created a symbol with the same name, or I got it, how I got it right. So what you do is, let me repeat it. So no, you have to open the schematic. And then I think the way I did it was that I opened the schematic, and from the symbol, I selected this option, make a symbol from schematic.
Okay.
So it automatically created a box with all the pins and everything there and typed in there. So you don't need to do it. If you create a symbol from the schematic, it would automatically bring all the pins and then make a shape, which might not be very good, but अभी करे नहीं क्योंकि आपने बना लिया ना. अगर आपने बनाना हो and you want to have all the pins, तो वो उसकी ordering भी खुद कर देगा, name भी खुद कर देगा, direction भी खुद ठीक कर देगा, और ये properties भी सारी जो हमने अभी टाइप की हैं ये ऑटोमेटिकली कर देगा. Open recent, I open my symbol. So everybody is done till this point, Z?
We don't really care if the symbol is in that shape, we're fine.
Yeah, exactly.
Okay, I'm fine. Just one symbol.
It's one time effort. Let's say आपने अगर एक op amp या एक कोई filter बनाना है तो everybody has created symbol, G?
That's the post at the bottom. Hierarchical close the start and
Name or basic by
Subtext.
whatever here, shift one and me.
So you think, yeah, insert text.
That's why.
Insert text करना तो वाला chickens insert text करना तो वाला वो खाली सिंपल ही है ना वो insert text और क्या
Okay, if you write it in the format at name, so it would know, okay. ये simply text ही है तेजी
ताकि simple insert करना तो you should be able to see what it is. I think simple is better. I think it's more possible.
I think it's not necessary. एक just symbolic representation है आप बेशक इसको AND gate बना ले और अंदर इन्वर्टर हो तो doesn't matter. अच्छा now सब का हो गया जी यहाँ तक. So now we would create a top level cell in which we invoke this inverter and we simulate. Let's say if we want to see the DC transfer characteristic, we want to sweep input and want to see what is the output behaving like. And then we maybe input a time domain pulse and see what is the transient response of the inverter. We could do that. So we press file, new schematic. Now I save it as my inverter sim, my inverter underscore sim. हाँ जी. So now the way you would invoke any other symbol, you again press Shift I and then go to the current working directory because the symbol is saved here. And then you bring up that symbol. OK. And then Control Z to zoom out. Right, so you see it. Now you see there are a lot of things hanging out. So maybe if I don't want to see this or the pin names or instance name, whatever, I could just disable them from the property that we set. Right, zoom out again. Now we have to tell the schematic capture tool where the model definitions of the transfers are. So we should include a library file. So therefore, for that, we again press Shift I. And I go to the xschem library, the generic one. Inside devices, I go to code. There are two types of codes, code and code shown. They are the only difference is that one shows the text that you write in and the other one does not show it. So both are practically same, but one shows what you write inside and the other one doesn't. So inside this, so now we have placed a placeholder where we would write the Spice code to include the libraries. So I press select it, press Q, and change the name to models. It's not necessary, but to make it more meaningful, we write it. Otherwise, S1 was already fine. So before you type anything here, it's always best to change this edit attribute to value. What you do is you selected the code, you press Q, and then you change the edit attribute to value. And then inside, now you would write the path to the simulation models for the devices that you have used.
So what we did was we created a new schematic and we added the symbol. The symbol already connected. It's not is it connected? Because of the same file name and because of the same pins.
So test it.
I just missed, okay. So I've just managed to do that. I just what you did afterwards.
So to test whether it's connected or not, you select the symbol and press E. So you go inside and you see it's connected. And then if you want to go back, you press Control E. You could descend into the hierarchy.
Up and down.
Yeah, exactly.
Now, I understand.
So now you're sure that your symbol is now actually linked to the.
Okay.
And next, to include the models of the devices that are used in this symbol, the pfat_01v8 and nfat_01v8, we have to include a library definition, which is in the Skywater PDK. So I press Shift I and I went to the generic xschem library, press devices, and then I chose code. There are two types of code and code shown. Both are practically same. The only difference is that code shown would show what's written inside and code would not show. Otherwise, there's no difference. But for library definition, we would include code because you would see now it's a long path and it would clutter your schematic view. So I simply added that and then I selected this. I press Q. I changed the name to a meaningful name, although it's not necessary, but you include it to show anyone else that it is containing the models. And after that, you would go to edit attributes and select value so that you are typing only the value and you don't change anything. And here you would add the library definition. So you would add a command .lib. Yes, if you put a star, then we comment. Yeah, .lib is the command where you through which you specify the library path and then you specify the path. So it is user usr, then local, then share, then PDK, then sky130a, then libs.tech, then ngspice. Inside ngspice, there's a file called sky130.lib.spice. We could cross verify it if you want. So user, local, share, PDK, sky130a. So an easier way is to go inside the path and copy the path. So let's go. ngspice until this is the path and then sky130.lib.spice. And when you fabricate the device, it would have a distribution of properties. So it's normally distributed with some typical values and some fast values and some slow values. So generally, we would like to simulate a circuit for a typical implementation. So when you fabricate the chip, it has a distribution of properties with a normal distribution. So what we do is we type TT space TT, TT telling us that it is a typical corner. So most of the devices fabricated would be lying inside this process corner. So it is that model that we are using. You could use a fast as well, fast, slow, slow, fast, and slow, slow. But generally, this
What is this?
TT means that the devices fabricated would on majority would be belonging to this process corner so that the distribution is normal, but main of the majority of the devices, 90% or more, would be inside this behavior. So properties of the devices would be inside this. So because devices, let's say if the channel resistance is, let's say 10 kilo ohms, but it could vary a certain percentage, right? But majority of the devices would have a mean value of 10K, maybe going up to 15K and as low as 5K. So, but very few devices would be having 10, 15K and 5K. So therefore, when you simulate, you would simulate with a typical behavior. So TT is the typical.
जबकि यहाँ पे
बच्चे आप ये अपनी वर्किंग डायरेक्टरी में यहाँ पे होगा, ये ऊपर होगा, इसमें तो ये आपकी वर्किंग डायरेक्टरी, इसमें तो कुछ भी नहीं है। आपका सिंबल नहीं आ रहा,
जी जो बनाई है मैंने वो नहीं
वो
आ
आपने सेव कहीं और किया होगा ना, फिर सेव, इसको सेव वहां पे करो।
देखिए
हाँ, ओपन लेन वर्क में कहीं कर रहे हो ना, इधर नहीं करना, आप जाओ। जहाँ भी किया, लेकिन वो आपकी वर्किंग डायरेक्टरी यूज करें, डायरेक्टरी करो। ये उसके पास में शायद इंक्लूडेड नहीं है, मे बी आपने जहां से रन किया ना एक्स स्कीम, वो डिफरेंट जगह होगी फिर। आप इसी से रन करेंगे तब ये इसके साथ link होगा, otherwise नहीं होगा। So the folder where you run the X scheme from should be the same folder where you're saving. इसको क्लोज करके दोबारा यहाँ से ओपन करेंगे तो फिर ये डायरेक्टली आ जाए। ठीक है जी। So with this command you have linked the told the X scheme where the model definitions are of the devices that you are using. And you have also specified the process corner. So typical process corner, so you press simply OK.
This schematic we have open or previous symbol in the new schematic, where we have written these properties.
GG.
We have to open or previous symbol.
So we have to import the symbol. Shift I, you insert the symbol. Shift I. Shift I. Then we up. You cannot say that you have been. यहाँ पे आप इसके अंदर आप सिंबल बराबर देंगे। ये आपने डायरेक्टली किया, लेकिन आप ये ठीक है साइन,
ये एक कमेंट है कि मैंने किया
So we did two things. We inserted a symbol, we provided the library definition. Next is to get up here hang हो गया। I should एक भी बच गया, हम थोड़ी देर में ब्रेक ले लेते हैं। Let's finish the simulation and then I save it now. So now we insert ये किसी का error तो नहीं आ रहा? 6 से ऊपर कर दिया है मुझे लगता है ये I don't know.
सर आपने इसको दोबारा स्टार्ट किया और परसिवियर व्यू किया
फिर नहीं मसला आया था. So now we insert a voltage source, one for the input, one for the positive supply, the VDD. We connect the ground, and then we try to simulate. So I'll do two types of simulation. One is the DC sweep. The other one is the transient simulation. So I go to again Shift I to bring the device. So I go again to the generic xschem library, devices, and I bring in the symbol ground, G for ground. This is ground. So I connect it to exactly V. Let's see again. W. If they connect नहीं हुआ W. Make sure it's connected. यहाँ पे अगर gap आएगा तो फिर it would not work. Then press W here. जी तो अभी मैं यहाँ पे वोल्टेज सोर्सेज और ग्राउंड वाला कनेक्शन देना चाह रहा हूँ तो अगर स्नैप हो रहा है ठीक है अगर स्नैप हो रहा है इस जगह पे तो ठीक है लेकिन इट्स पॉसिबल कि स्नैप ना हो रहा हो अभी यहाँ पे भी आपको गैप नजर आ रहा है ये कनेक्शन नहीं होगा सो आई क्लिक एंड नाउ इट इज कनेक्टेड ठीक है ओके नाउ ये भी नहीं हुआ यार मे बी स्नैपिंग में इसकी 5 कर लूं शिफ्ट जी जी पैटर्न आई थिंक 5 से हो जाएगी
You don't need, the wires are not necessary, connected directly.
If it's snapping, fine, then it's fine. अगर नहीं snap हो तो फिर Okay, now I bring in a voltage source, so Shift I again. And I go to again generic xschem library. At the bottom, we have V source. The fourth to the last V source. And I place it here. I copy ground, C, paste it here. Then I click and drag to select. And press C to copy. And place it here to paste. So now I have two voltage sources, V1 and V2. So I set V2 to 1.8 because it's a 1.8 volt device. So I select the source, press Q, and change the value to 1.8. And similarly here, it doesn't matter because I will be sweeping this voltage source. You could even rename the sources to make them more meaningful. Let's say I could call it VDD. And I could call it VN. Again, it's a aesthetics choice. It's not necessary, but so now I need to tell the simulator to sweep the voltage Vn from 0 to 1.8 volts and maybe save some node voltages. If you want to, if you don't name a node, it would name net 1, net 2, net 3. So if you want to plot, it's good to name these net. So I go to tools again and insert wire label, Alt L. I click this. I press Alt R to rotate. Press it here. So now this net or this node is named XXX. I could change it by clicking Q. So I label it as out. And similarly, I could create a label here, Alt L, and press Q to call it N. So these are now the net names. So to do the DC sweep simulation, we need to bring up another code like that. And for that, we need to make it a code shown so that you see what commands you are writing. So again, I go to insert symbol, Shift I, and from the top, I choose code shown. As I said before, whether you choose code or code shown, it is practically the same, just that the code shown would show you the commands written inside. And generally, if you are simulating, it's good to see what you are trying to simulate. So I again press here and press Q. I'll be a little slow here. So now I name it as spice, and then I change the attribute to value only. Now here I'll type several commands. So let's say if I want to plot the voltage at the node called out. So I would use a command called dot save. And then I name the node. So I would write V of out, V bracket out. So what it would do is it would save all the values of output vector for every iteration of the simulation.
Save.
Dot save and V of out. And then we could even try maybe writing dot save all. Let's see what happens. Instead of writing dot save V of out, I write dot save all. So it should somehow save all the vectors for voltage and currents.
Save all.
All, yeah.
Still, this should be the code.
Shown.
It's not save the out, it's save all.
Yeah.
Okay, so we're saving everything.
Yeah. And next, to tell the simulator that we want to sweep the voltage Vn, we would write a dot control block. So dot control, and it ends with dot end C, end control. And inside that, you would write some commands to tell the simulator what you want to do. So I would like to do a DC sweep. I write DC, and then I name the voltage source which I want to sweep. So it will be Vn. DC is the command which tells us that we are doing a DC simulation or DC sweep. So DC Vn, then I give the starting value of the voltage source, which is 0. And then I give the ending value, which is 1.8. And then I give the increment value. So from 0 to 1.8, what should be the increment or the step size? So 0. Let's say 0.1, which is 10 millivolts. What I've done is I am asking the simulator to do a DC sweep for the voltage source named Vn. It should start from 0 volts. It should go up to 1.8 volts and with a step size of 0.01. And then let's say I want to plot the voltage V out. So I would write plot V of out. I expect that since we have written the command dot save all, it should save all the voltages and currents. Exactly, जो node name होगा उस node name को आप यहाँ पे लिख देंगे. V ये बता रहा है कि it's the voltage of a node. अगर ये आपने नेम ना दिया होता तो फिर वो यू हैव टू सी कि इसका नोड नेम उसने नेट 1 नेट 2 नेट 3 क्या दिया हुआ है। Okay, I'm pressing OK and I'm saving it. So before you simulate or proceed, do one more thing. Go to simulation and check this. Use simulation directory under current schematic directory, which we have already created. So we created a simulation directory before we started. So just check that. And it should now it should be fine to, I think, now simulate. Once you are ready, we could try to simulate now. See, it's
So we have in, we have out. Whatever you say, yeah. We have choice. This one.
It's common. So say the Alt L say. Alt L would create a label for the node. Alt L. बस को rotate Alt R से करने का भी Alt R. सारा सिंबल नहीं रखते फंडामेंटल अगर बन रहा है so now as I said in the beginning during the slides, the spice is not able to run this schematic. So we have to create a netlist, a textual description of the same circuit. I would press netlist here. And then I go inside the folder. If I go inside the simulation folder, you should see the same schematic file name with a .spice extension. So my inverter underscore sim.spice. ये कहाँ पे होगी? It be under the simulation directory. Okay, आपने जो वहाँ पे जो third line पे check किया था, that was selecting the आपने यहाँ से किया. Before you are able to do that, आपने simulation में जाके use simulation directory under the current schematic directory. If you have created it, then it should. Netlist दोबारा करेंगे तो वो. If you open it, you would see that all the commands that you wrote inside Spice, and those even those that you didn't, आपने फिर वो Spice netlist नहीं की होगी. Oh yeah. I think I have to stop again. मेरे साथ इसकी दुश्मनी है. It's taking time.
We take with the meaning of name.
So you see now, इस circuit की जो description है वो exactly as it is, उसने netlist create कर दी है, ठीक है? Any devices that you have, library additions, type of simulation you want to run. अब आप simulate कर दें जी. It should work. Next step is to, once you have created a netlist, simply press simulate. It should take some time. We need X key. Now click simulate next to netlist. Wait a few seconds and you want to see. Yeah, बंदा है वो अकेला लगा हुआ था उसके लिए सारा
कोई कम्युनिटी बेस्ड नहीं आता है कम्युनिटी बेस्ड एक ही बंदा बनाता है
एक बंदा ही मेन डेवलपर की वेबसाइट है opencertifying.com उसके साथ में कोलैबोरेटर्स हैं लेकिन नहीं है
और ये आगे ये क्या आपने सर ये क्लास मैं एक्सेप्शन लॉगिन हो जाएगा सभी नेटलिस्ट को एक बार
मैं देख लेता हूँ
my first concern. My estimation of my single size. It's fine.
इसके अंदर से बना दिया आपने। Netlist, I should be able to see netlist inside simulation folder. I could open it. So you see that there's a this is the circuit. X1 is the inverter that we have created. So it is input is net 1, output in and ground. So no. Net out in and ground. So it's a problem. Pretty गड़बड़ है. So I need to open. Inverter dot. In. अच्छा कुछ चेक कि आपका जो स्कीमेटिक ये बनी है स्पाइस फाइल बनी है इसमें जो ये लाइन है व्हाट इज द ऑर्डर हियर मुझे ये बताएं जी सर कि व्हाट इज द ऑर्डर हियर x1 क्यों मेरे पास मुझे लगता है कि ये गड़बड़ है
पास ऑर्डर देखने की पहला क्या है मेरा पता है x1 first x1
next one is the instance name no? Then the pin order could be in out let me see गड़बड़ लग रही है so I open the P4. Let's see. So now For me, it's working. अगर ये current directory ना भी हो तो it would work because it would save somewhere else. Then you could never simulate. But if you want to see the netlist file, then you try to
ये इसको प्लॉट करना से वो नॉलेज देखना मतलब बी बड़ी की वैल्यू जो है हमने यहाँ पे ये है तो बड़े बड़े क्लाइंट्स हैं तो you know right it's not about that to make few parameters for subset plus if myself switch to the ground one point eight out और महीना ये इसका मुझे क्या निकल पड़ा है इसके मुझे तो नहीं करेंगे तो don't eat six when you decide to get one because दोबारा नहीं इसमें few parameters for such circuits like first instance.
वहाँ पे काम के चालू होकर करने पड़ेंगे अभी के बनी
schematic हो गए schematic कहाँ आएगी
ये ऊपर है वो लाना ऊपर इधर सामने आ गया तो हम रिटर्न सिस्टमैटिकली इसे यूज कर सकते हैं तो यार ऐसे चीज लिखी रहती है मैं सारा एडिशनल एप्लीकेशन और ये आइसम माना ले कर रहा हूं दावा शिफ्ट है शिफ्ट इसकी मैं कई विलेज रिपोर्ट को डबल फॉर्म स्टेप तो सब यूज करते हैं ध्यान देना चाहिए हाँ उसके नहीं लोग डिमांड करते हैं तो बेकिंग हमें हैंडल से डॉट लेफ्ट नेक्स्ट इस तरह में यूएस नहीं कर रही है फाइल करना सर तो सॉरी मैं विलेज कलर से
ये ध्यान रखना in the schematic when you are trying to connect you would not use L line is dummy thing आपको वायर यूज करनी है ठीक है
मैं कह रहा था कि कलर नहीं था लीव वाला टू आर सी एच
if you are getting an error then clear the button इसके बाद करो इसको मिनिमाइज करो ऊपर नेट के साथ सेपरेट है ठीक है नेट सेपरेट उधर जाके देखो बनियन से ये आप कह रहे हो मैं भी लेक्चर नॉट कर रही है शॉर्टेड ground ability ground you have the base
wire space like
आपने कॉल स्टेप नहीं दी थी ठीक है
let's see the whole division
मुझे लगता है कि ये नेटलिस्ट बन जाती है एक फ्रेश ये अभी नेटलिस्ट तो ये फिर इनेट मोड में चाहिए सर ये है लोग कंप्यूटर का एक मिनट कुछ लेक्चर ना
नहीं सब यही है
ये बड़ी एग्जाम को बड़ी क्यों
पहले
सिलेक्ट मैं भी नेटलिस्ट का वही
क्या क्या
एक सेकंड that is really exactly that's how we should do that extra
पहले यार तुम्हारा शॉर्ट वाला सवाल था
नहीं यार ये तो डीटीपी बड़ी सुनो
ये सेंसिटिव इसलिए ये क्यों करेंगे ठीक है
एक सेकंड ये हम नेटलिस्ट करते हैं हाँ वो
ये आप इसको कॉपी करो
क्या
ये सिस्टम ठीक है सिमुलेशन का मतलब दो केस सिमुलेशन है ठीक है उन केस के साथ नहीं वो ये फोल्डर लिखा हो स्कीमेटिक का तो ये नेटलिस्ट ये काम आपका सब सर्किट क्यों नहीं आ रहा one in ground not saved by one इसने आपको कहा अपने कहीं कहाँ से देखें not saved by आपका सब सर्किट नहीं आ रहा ना so let me take it now keep it after this one spouse the rent to the university how to one thing on the side it's क्या mind better use some
yes very good yeah
and it would be my money is application we'll find the big presentation use for Is maybe it's the dog. One, two, generic names are constantly scale image. This scale except for parameters, parameters first. If you want to can same. How could we same names are as now show me the direction. Yeah. Yeah, then power starting. It was spent. सिंपल आना चाहिए एक्सपांड है इसमें ना देखिए ना कहाँ पे है तो ये Sorry. इसका नाम जो है इस ये एक इंस्टेंस ऑफ पर्सन ऐसे हमने वो किया था कि एक्स को भी रखते हैं उसका अपनी पैरेंट्स issue after we looking at the value of that. It's a simple concept. वहाँ पे जब आप ये
अभी किसी और भी सॉल्यूशन
ये देखिए
और नहीं
सिंपल क्या सब सब
आपको मसला ये है कि आपके सिंबल inverter constants and now type everyone I think is having issue in the symbol. So please open the symbol file. No. The symbol file press Q. Edit text property वाला आपका आ जाएगा उसमें type equal to sub circuit. Then जो बाकी दो कमांड्स भी थी वो आपने अगर नहीं लिखी तो से आ जाना चाहिए अगर आपने नहीं लिखा है टाइप click anywhere else in the background. Now press Q. यहाँ पे आपने लिखना है ठीक है. Let me show what I mean. Schematic. Okay. See, so you open the symbol inverter dot sim, right? Then click anywhere in the empty space. You should get this. You press Q करके कर लेना ठीक है. तो type should be sub circuit. Format is equal to @name, @pin list, @sim name, and then template is equal to name is equal to x1. So yeah, I think this is this most important thing कि आपके पास जो स्पाइस में वो क्रिएट करेगा तो वो @name x1 ठीक है. उसके बाद पिन लिस्ट आपकी आ जाएगी और उसके बाद आपके पास सिंबल नेम ठीक है. फिर कर लिया जी सबने नहीं किया इशू अगेन आप उनकी सिमुलेशन रन नहीं हो रही ना @pin list @sim name ठीक है. ये इशू नहीं है, ठीक है, ये डायरेक्टली कनेक्ट हो जाता है, ये जो ग्राउंड वाला इट कनेक्ट्स। रन होगी जी सिमुलेशन, इन्वर्टर का आ रहा है सही। आपने लगता है कनेक्शंस में आर एस को इशू किया है,
सर लेबल्स का इशू होता
गलत जगह पे कनेक्ट कर दिया होगा।
है। रन हो रहा है सर, तो सर ग्राफ दिखा कि कोई कनेक्शन के साथ नहीं है।
But the next thing I would do is, before we go to break, is the transient simulation. It's the same circuit. We simply change the DC command to tran command and the input from being a 3-volt source to a pulse. Okay. So I save it as my inverter sim underscore tran. Okay. And I would now change the type of source here. So I click the source, press Q, and I select value. Instead of 3, I would write pulse in bracket start. So in the pulse, you need the on voltage, which is 1.8 volts, the off voltage, which is 0. So then the time delay with which the pulse starts, we take it to be 0, let's say. Then the rise time of the pulse, right? So it would be, let's say, 1 nanosecond. Then the fall time of the pulse, which also should be 1 nanosecond. Maybe write 1s. Then the time period of the pulse width should be, let's say, 1 microsecond, and the on time, I think T on. One of them is T on and the other one is the pulse width. Let's do it this way, 0.5 microsecond, and see. So this is the way you set up the pulse. On voltage of 1.8, off voltage of 0, time delay of 0, rise time of 1 nanosecond, fall time of 1 nanosecond, the pulse width of 1 microsecond, and time period of 1 microsecond and pulse width of 0.5 microsecond. Yeah. So, and then I would change the simulation from DC to transient. So I click on this block, press Q. Instead of DC, I write TRAN, and then I would write the step size. The minimum step size is 1 nanosecond, let's say, and then the total duration of simulation. Let's say if the pulse width is 1 microsecond, I do it for 2 microsecond, so that I see 2 cycles of the pulse. Tran 1 nanosecond and 2 microsecond. T step and T stop. Let's see. If I've forgotten anything, it would tell us a show. Okay. एक और काम मैं करता हूँ यहाँ पे कि मैं instead of plotting V out, first I would like to see what V in is. V of n. So I create a netlist again and then simulate. Let's see. If the order of the pulse width and duration is different, it would give us an error. And It's wrong, right? So we have to change the. So here, all I need to change is 0.5 microsecond and 1 microsecond. Then recreate, exit it, save it first, recreate the netlist and simulate. Now you see, I'm seeing the input pulse, and without changing the schematic and recreating the netlist, I can type a plot command here as well. I could simply type plot v of out, and it should plot the output. If you want to export the data to a text file, um, you could see the detailed command manual in the ngSpice manual that is available free online. I think it's WR data. So WR data would write the data as a text file, and then I need to write the vector. So v of n, let's say, and space v of out. If I do so, WR data space v bracket in and v bracket out, it should write the data. I should maybe now check. I think maybe I need to write the. Let's quickly. ngSpice manual. You don't need to memorize the commands. Like if you forget for the pulse, you could check it always in the ngSpice user manual. Let's say if I want to search for pulse. Here you see, it gives you the form V1, V2, T delay, T rise, T fall, pulse width and period, right? So right now I want to see WR data, WR data, WR data. File and then vectors. So output, right? So now I go back. Maybe inside the parentheses we need it. I think you could explore the commands. Let's say मैं सिर्फ v out अगर करना चाहूँ कर रहा है? मेरे पास क्यों नहीं कर रहा?
तो ये आपके वो सिंबल है मेरे इसे एकदम कर रहा है।
कहाँ पे है आउटपुट? मैं इसको दे रहा हूँ. अच्छा, I see.
और ये फोल्डर आपका